about rationalizing the denominator, which means you cannot have a radical left in the denominator. So we're going to start with example 1. Okay, so the main goal of rationalizing the denominator is so you will not have that radical left in the denominator. All right, so let's do example 1. And let's take 4 rad 2 divided by, let's say, rad 5. So right now you see there's a radical in the denominator. So we have to make that what we call a rational number. That means simply a number that does not have the square root around it or the radical around it. So what you do is you multiply by the denominator. So when you multiply a radical times itself, because let me show you, like if I gave you this and say, what is rad 5 times rad 5? Well, obviously we know 5 times 5 is 25, which equals to what? 5. So basically when you multiply a radical times itself, you just end up with the number under the radical without the radical. Okay, you end up with that radicand, but it doesn't have the radical around it. So that's what we're going to do. That's how we rationalize the denominator, is multiplying by the denominator. And obviously, if you multiply the bottom, you have to do the same thing to the top, regardless. Okay, so now at the bottom, I'm going to have the square root of 25, which is 5, which is what I wanted. I wanted a rational number. And then remember, you can only multiply radicands to radicands, outside numbers to outside numbers. So it's like an invisible 1 here. So 4 times 1 is 4, and 2 times 5 is 10. Now, sometimes after you multiply, you can simplify the radicand, but you cannot simplify 10. Okay, it is in simplest form. So that's example 1. All right, example 2. Okay, so say we had something like this, 5 rad 10 divided by rad 6. Now, one thing you can do is you can make numbers smaller if you can reduce them. So like inside of here, says both are radicands, I can actually reduce 10 over 6. Like if that didn't even have, say I just had a fraction called 10 over 6, how would you reduce that? 5 over what? All right, so we can do that. And do you have to? No, it just makes your numbers smaller, so you're not having to simplify big radicands later. Okay, but you could leave it as rad 6 and then multiply top and bottom by rad 6, but it does make it a little bit easier when you can just take a smaller number, and then we're going to multiply the top and bottom by rad 3. Okay. All right, so we'll multiply our outside numbers. That'll give us 5. Inside numbers will give us 15. And at the bottom, the square root of 9 is 3. And that's really all it is to it. Okay, it's not a difficult concept to grasp. All right, let's do another one. Okay. All right, so let's say we had 4 here at the top, 2 at the bottom, and then we had rad 7. Now, just like we reduced the 2 radicands, we can also do the same thing to numbers that are on the outside. So we can also reduce that as well. Okay, so what's 4 divided by 2? So really, we're going to end up with 2 over rad 7. Is that correct? Because we just simply say 4 divided by 2 is 2. All right, so what do I do next? How do I get rid of the rad 7? times it by rad 7. Very good. So that's going to give me rad 14 over 7. Now, I cannot reduce this 14 and 7. Why? Because one's under the radical and one is not. Okay? So they both have to either be under the radical or they both have to be outside the radical. All right, now another thing you're going to see when you do the around the room today, besides the exponent rules, which I'm sure you guys are comfortable with, but you also are going to see some problems where you have to add and subtract with radicals. So I just want to review that. Okay, we did this lesson, I think it was unit 7. Okay, so we can put a title that says add and subtract. Now, when you add and subtract radical expressions, you can only add or subtract if they have the same radicand. Okay, so for instance, if you had 2 rad 3 plus 5 rad 3, okay, you can add the 2 and the 5 together and say, I have 7 rad 3s. All right, now sometimes you have to, let's say you had 2 rad 7 plus 3 rad 24, okay, plus rad 7. So what I notice here first is 24 is not in simplest form, okay, because it has a perfect square in it of 4. So if, or you can, you know, and you guys will be able to use calculators, but if I do this by hand, I'm going to break down the 24 to 4 times 6. Okay. Now, when I do that, I'm going to take the square root of 4 out and multiply it by the 3 that's on the outside. So this part in here is actually going to give me what? 6 rad what? 6 rad 6, correct. Now, the only 2 radicands I can actually add together is this one here and this one here. That's it. So I have a total of how many? 2 plus an invisible 1 will give me a total of what? 3. So 3 rad 7 plus 6 rad 6. And it doesn't matter if you wrote 6 rad 6 plus 3 rad 7. Okay, the order doesn't matter. Okay, so just to kind of recap on, you can only add or subtract if they have the same radicand, and you want to make sure that those radicands are in simplest form before you start combining them together. Okay.